So, hi all. Today we are going to look into the topic of switching network. So, basically, switching networks. So when we communicate over a long distance, like we might not be just needing a sender and a receiver. We might need some intermediate nodes through which the data can be passed. These intermediate nodes are not concerned about the data content. They will just pass the data from one node to the another node. This is the role of the node. Okay, so end devices are called stations. So basically, stations is nothing but a computer or a PC with the mobile phone, and that's what a station like. Examples of stations is mobile phones and a computer. Computer, mobile phones, or any other terminals are called as stations. So the next topic is nodes in a switched network. Nodes connect to other nodes or stations. So nodes will only be connected. It can only be connected to a node or to the station. It will not be connected to any other thing. It may connect from one node to another node, or it can be connected to a station. So node to node links are usually multiplex. So what do you mean by multiplex is that they share the same physical link. They share the same physical link. Like multiple signals share the same physical link. Most networks are partially connected. They are partially connected, stating that they are not fully connected, and some redundant connections are always there in order to improve the reliability. So there's two switching techniques: circuit switching and packet switching. And in this presentation, we will be mainly focusing on the circuit switching. So before getting into circuit switching, we will be just looking into simple switching network. So basically, in a switching network, the circuit switching, uh, so in simple switched networks, data flows from source to the destination through multiple switching. This just like the explanation for this is that data flows from one station and passes through various nodes and finally reaches the destination station. Each node decides the path or the next path for the data. Like the data is being transferred from one node to other. Then yeah. So then we are going for circuit switching. This is when we get into the topic deeply. It is mainly dedicated communication path between two stations. So, circuit switching is a technique where a dedicated communication path is being established between the two stations before data transmission begins. Path is established before data transfer. The path is being established before data transfer. So, before the communication takes place, a fixed path is being established, and this path will remain for the entire session. Even if it's being used or not being used, this path will be present for the entire course of the communication. So the best real life example is the telephone network. Like whenever we make a call, there is a separate path or separate fixed path between the caller and the receiver. This path is this path will be used no longer if the person is communicating until and unless the call hangs up, or like when they stop the conversation. Not to stop the conversation, when they stop the call. Until and unless the call or the path will be assigned to the circuit, will be assigned for that particular communication. So, phases of circuit switching. So, mainly there are three phases: connection establishment, data transfer, connection termination. So, from the terms, it is quite clear that establishment phase is the phase where a path is being set up between the sender and the receiver, which is find a free route and reserve the resources. Or like resources in the sense, in this it is meant the path. And the next stage is data transfer. In data transfer, this is the phase where the actual data transfer takes place. Once connected, data flows continuously with no addressing required. It won't halt. In the connection establishment, route is identified between the sender and the receiver. Switching and channel resources are reserved. So, from the term establishment, as I already said, a path is being set up between the sender and the receiver, which is find a free route and reserve the resources. Find a free route and receive the resources. Then data transfer phase. So this is the phase where the actual data transfer takes place. Continuous data transmission. Once the data transfer is started, it is not stopped. I mean, it is not halted at anywhere until and unless the data transfer gets completed. So it is continuous. There is no discontinuity. No addressing required after setup. Low delay and reliable communication. Next is connection termination. From the word termination, it is clear to us that the connection is being disconnected after the communication so that the resources are available for or the path is available for other circuit or like for other users. So, some of the applications of circuit switching is that the application for circuit switching is that it was mainly developed for voice communication. Developed for voice communication, traditional telephone network. One of the disadvantages where we could come across is that uh, next going into the characteristics. So some of the characteristics of computer is that this topic is dedicated path. The path is being fixed for that particular communication. Fixed bandwidth, low latency, inefficient during idle period. It becomes inefficient during the idle periods, like when it's not being used. That is one of the disadvantages. Advantage. As far as the advantages is concerned, guaranteed bandwidth, it is reliable, and there is no pocket loss. Regarding the pocket loss, it will be dealt in the pocket switching, not in the circuit switching. Then disadvantages, there is a wastage of bandwidth, connection setup delay. So it might take time for setting up the connection as the connections might be difficult in some of the complicated situations. It is not suitable for data communication. Next is public circuit switched network. So subscriber. So by the term subscriber, it is clear to us that it is the users, like users or the devices like telephones which is being connected to the network that we can be called as a like the device telephone can be called as a subscriber. Subscriber line. Before going to subscriber line, let's come for like let's see the exchange. Exchange is that switching center, switching center that establish and manage the connections. Switching centers and that establish and manage the connection. Now we are coming to the subscriber line. The subscriber line is the physical connection between the subscriber and the exchange. And we also have trunk. Trunk is high capacity link between every exchange. Next, we are going for circuit switch component. Some of the circuit switching, like for establishing a circuit, the basic components are network interface, control unit, switching fabric. Now, blocking versus non-blocking. So, blocking network cannot cannot always be available for path. Cannot be available for all stations at all time, because sometimes all the path may be busy. It can be busy. It is acceptable. It can be busy at some time. Not every time, but sometimes it can be busy. And non-blocking, it allows all the connections simultaneously. Like it allows all the connections, all the stations to be connected simultaneously. It is expensive. It is expensive and complex. Phase division switching. It uses a separate physical path. It uses a separate physical path for each connection, which might be expensive, and it can lead for too much of crossbar. Crossbar in the sense, crossbar switch is an example. Too many cross point. This might be a drawback, and inefficient usage. Large number of cross points required is a drawback. Inefficient usage. Hardware failure affects the connection. If it results in hardware failure, then obviously it will the affect the entire circuit. Multi-stage switching. This reduces the number of cross point but increases the complexity. Reduces the cross point but increases the complexity. It can be blocking as well. Time division switching. It uses time slots instead of physical one. It is quite common in modern digital systems. Multi-stage, sorry, uh, modern system use time division switching. Time slots are allocated instead of physical path. Time slots are allocated instead of physical path, so that it is being used only at that mentioned time and not at any other time. And at last, the last topic is, I mean, the last term is this soft switch. Separate call control from hardware switching. This has a separate call control from hardware. Like it separates the software from the hardware. This enables VoIP and advanced services. This allows features like voice over voice over IP. VO stands for voice over. And like the summary, or like just coming to the end of this circuit switching, is that it uses a dedicated path. Three phases are involved. It is reliable for voice communication, inefficient for traffic. Like if there is too many networks, this might not be the apt, or like this might not be the best possible. It might not be the best thing to have. Like we can go for the packet packet switching instead of circuit switching, and three phases are involved. We have seen it is reliable for voice communication. Like it can be mainly used. One of the major advantages is that it can be used for telephonic call. Like it, and also when you are talking about telephonic calls, they we might need a dedicated path. That dedicated path is being presented, or like it is being given to us by this circuit switching. And and I guess we have come to the end of this video, or like the end of this session. And of the session, like on further progress, we might be looking into packet switching. And thank you for the opportunity and thanks all.